Let's examine the gradient of a curve. So when we started our discussion on differentiation, I told you to think of differentiation in terms of just finding the gradient or slope of a curve. So now we mentioned that differentiation is given as dy dx. So when you find dy dx of a curve, what you are doing in essence is finding the gradient or the gradient function of the curve. And to explain what I mean by that, we are going to look at two cases: when the curve is a line and when it is a parabolic or a quadratic curve. So let's get started. Let's talk about the natures of straight line. So now look at this straight line that is being marked by this blue line over here. We are given the equation of this line to be given as 2x plus y equals to 2. So now if I make y the surrogate of formula, I have y is equals to minus 2x plus 2. Now if you remember our discussion on equation of a straight line, I told you that the general form of the equation of a straight line is given as y is equals to mx plus c, where m is the slope and c is the intercept. So if I compare these two equations together, I can see that my m is equals to what? Minus 2. So that is visible. My m is what? Minus 2. That means the slope of this line is minus 2. So now let's try to differentiate the equation of this line and see if we get the same answer. So the equation of this line is given as y is equals to minus 2x plus 2. So let's try to evaluate dy dx. So dy dx will be given as what? When I differentiate minus 2x, I have minus 2. And when I differentiate 2, which is a constant, I have 0. So dy dx is minus 2. And as you can see, this corresponds to what we got when we read out the slope of the line directly. So in other words, you can see that the differentiation of the equation of the line gave us the slope. And that's what I mean when I say that differentiation can also be thought of as finding the slope of a line or curve. Now let's extend this idea to a cubic curve. So now we have this curve over here, as you can see, and we're told that the equation of the line is given as y to be equals to minus 4x cubed plus 3x squared, then plus 25x plus 6. So now we're told to find the gradient, or want to find the gradient of this curve. So how do we go about this? As I've explained, all we need to do is just to differentiate the equation of this curve. And by differentiating, I mean we should find dy dx. So dy dx will be equals to, now based on our rule for finding differentiation of algebraic functions, then this 3 comes down here. So I have minus 4 times 3, which gives me minus 12x, and the power reduces by 1. So I have 3 minus 1, and I have 2, then plus 3 times 2 gives me 6, then x, then this becomes plus 25, and this 6 becomes 0. So now if you look at this carefully, what you will notice is that the gradient is given or expressed in terms of x. In the previous example that we solved, we saw that the gradient was a singular number which gave us the slope. But in this case now, we are finding that the gradient is given in terms of x. And why is that? Because we know that for a straight line, the slope along the line is always constant. But for a curve, the slope along the curve depends on the position you are on the curve. So the slope here at this point is different from the slope at this point, which is different from the slope at this point. So what we have here is the gradient function. So based on the gradient function, for any value of x, if you know for any value of x, we can substitute it here and find the gradient of the line at that particular point. So in terms of finding the gradient of a curve, what we have is the gradient function. The gradient function. So based on this function, we can now find the gradient at the particular point in a curve. So let's look at some real examples to illustrate this point. So here we are told to find the gradient of the curve y is equals to x squared plus 3x minus 1 at the point of it where x is equals to 3 and x is equals to minus 2. So we have a curve given by this function, and we are told to find the gradient when x is 3 and when x is minus 2. So the first thing we want to do is we want to find the gradient function. So we'll find the gradient function by differentiating the equation of the curve. So again, this is the equation of the curve. So to find the gradient function, we just have to differentiate. So we have dy over dx is equals to, so when we differentiate x squared, we get 2x, and when we differentiate 3x, we get 3, and this minus 1 becomes 0. So I have my gradient function dy dx to be equals to 2x plus 3. So now we're told to find the slope or the gradient when x is 3. So when x is equals to 3, what is the slope? So dy dx when x is 3 will be equals to what? We substitute the value of 3 into this equation here. So we have 2 into bracket 3 plus 3, and that becomes what? 6 plus 3, and that results in 9. So at the point in which x is equals to 3, the gradient of the curve is what? Is 9. So now let's look at the second instance, and we are told to find the gradient also when x is equals to minus 2. So again, we just substitute the value of x as minus 2 in the gradient function. So dy dx will be equals to 2 into bracket minus 2 plus 3. And what does that give us? So 2 times minus 2 gives us minus 4, and minus 4 plus 3 gives us minus 1. So when at point x is equals to 3, the gradient is 9, and at point x is equals to minus 2, the gradient is minus 1. So as you can see, when we have a curve, the gradient is dependent on the position you are on the particular curve. So let's move on to another example. And in this example, we are told to find the points on the curve y is equals to this at which the gradient is 15. So we have the curve given by this expression. We now ask that at what point on the curve is the gradient 15? So the first thing we want to do is we want to find the gradient function or the gradient of the curve. So now we are given the equation of the curve as y is equals to x cubed plus 3x squared minus 9x plus 3. So we can find the gradient function by differentiating this expression. So we have dy over dx is equals to x cubed becomes 3x squared, then this becomes plus 6x, then this becomes minus 9, and this 3 becomes 0. So after we've gotten that, now we are told that the gradient is what? The gradient is 15. So we are told to find the point at which the gradient is 15. So here we are told to find the points, when the gradient, which is dy over dx, is equals to 15. So we substitute the value of dy dx as 15 into this expression. So that becomes 15 is equals to 3x squared plus 6x minus 9. So what am I left with? I have 3x squared plus 6x, then this becomes minus 9 minus 15 is equals to 0. And that becomes what? 3x squared plus 6x minus 24 is equals to 0. So as you can see, I have gotten a quadratic equation, and I can easily find the values of x. So to find the value of x, I have to factorize the equation, and to factorize it, I know that 3x squared plus 6x minus 24 is equals to 0. So to factorize, I multiply the first and the last term together, and that gives me minus 72x squared. And I ask myself, what two numbers would I multiply together to get minus 72x squared? When I add them together, I'm going to get 6x, and that those numbers turn out to be 12x and what? And minus 6x. So I replace 6x with these two expressions here. So I now have 3x squared then plus 12x minus 6x minus 24 is equals to 0. So 3x is common, and when 3x is common, what am I left with? I'm left with x plus 4, and here minus 6 is common, and I'm left with x plus 4. So I have either x plus 4 being equals to 0, or 3x minus 6 being equals to 0. So in this case, my x is equals to minus 4, and in this case, my x is equals to 6 over 3, which is equals to 2. So now I found 2 points on the curve at which the gradient is 15, and those 2 points are when x is equals to minus 4 and when x is equals to 2. So what I have to do now is to find the corresponding value of y so I can pinpoint the coordinates. So now when x is equals to 2, I can find the value of y, and to find the value of y, I just substitute it into my general equation that was given. So my y value will be what? My y will be equals to, my x is 2, so I have 2 cubed plus 3 into bracket 2 squared, then minus 9 into bracket 2, then plus 3. Now when you punch this into your calculator, all this works out to be 5. And in the second instance, when x is equals to minus 4, you can punch it into that function to have y is equals to 4 cubed plus 3 into bracket 4 squared minus 9 times 4 and plus 3. So my y value now will be equals to 23 when you solve all this. So now the point at which the gradient is 15, we have 2 points at which the gradient is 15, and those 2 points I'm going to write them inside the coordinate. So the first point, when x is equals to minus 4, my y value is equals to 23, and when x is equals to 2, my y value is what? 5. So these are the 2 points in which the gradient is 15. Now let's take a look at one more example. So in this example, we are told to find the equation of the tangent to the curve y is equals to x squared minus 4x plus 3 at the point 3, 1. So to explain this, I'm just going to try to draw a sketch of this curve, and you should note that this is in no way the appropriate sketch. This is just to give you a pictorial understanding, but this in no way represents the curve. So we have a curve. So let me assume this is the curve, and we are told that the equation of this curve is y is equals to x squared minus 4x plus 3. So now we are told to find the equation of the tangents to the curve at point 1 and 3. So let me assume that at this point here y is 3, and at this point here x is 3, and at this point here y is 1. So when I trace that point out, here is 3, I have this particular point here. So now when I have this point, I'm told to find the equation of the tangent to this point. So when I draw a tangent to that point in particular, so this point touching, I'm told that the coordinates there are 3 and minus 1. Now I'm told to find the equation of this tangent. So how would I do that? The first thing I want to do is to calculate the equation or the gradient function of this particular curve. And to find the gradient function of this curve, I know I have to differentiate the equation of this curve. So for the curve, I'm told that y is equals to x raised power 2 minus 4x plus 3. So the gradient function, which is dy over dx, will be equals to what? It will be equals to 2x minus 4. So now that I've gotten the gradient function, I know that at this particular point here, what is the value of x at this particular point? At this particular point, the value of x is 3. This is value of x and this is value of y. So I can find the gradient when x is equals to 3. So when x is equals to 3, the gradient dy over dx will be equals to what? Equals to 2 into bracket 3 minus 4. And that will be 6 minus 4, and that will be equals to 2. So the gradient at this particular point is what? Is 2. So now that I've gotten the gradient at this particular point is 2, since we know that the tangent is touching this particular point, we know that the gradient at this point and this line are going to be the same. So the gradient of this line we can say is also what? 2. So the slope of the tangent, so we can write that the slope of the tangent slope of the tangent is equals to 2. So now that we know the slope of the tangent and we know a point of the tangent, because you know that the tangent pass through this point, and we know, so we can calculate the equation of this tangent. And to do that, if you remember our formula for calculating the equation of a line, we said that y minus y1 over x minus x1 is equals to m, where m is the slope. So now we know one of the points of our tangent, and that point is what? 3,1. So our x1 is equals to what? 3. Our y1 is equals to 1, and our slope m is equals to 2. So we can substitute it here. So what do we result in? It results in y minus 1 over x minus 3 is equals to our slope, which is 2. So if we cross multiply, we have y minus 1 is equals to 2 into bracket x minus 3. So we have y minus 1 is equals to 2x minus 6. So that becomes y is equals to 2x minus 5. So the equation of the tangent of this line, which is the tangent at this particular point, is given as y is equals to 2x minus 5. So this explains how we can use differentiation to calculate the equation of a tangent to a curve. So that pretty much sums up the idea of this form of application. So let's move on to another application of differentiation.